Thank you very much again for coming and joining us for our monthly webinar, which we have been organizing for some time under the Nile Talk Forum. So as we say always, this is a forum that brings expertise on Nile and transboundary river issues from different parts of the world, from different river basins, mainly to share their experience, which actually help us in diffusing tensions and how can we actually share the common good, build trust, and also develop collaboration and cooperation. So we were very successful in bringing different expertise monthly. So I would like to thank our co-organizers. This is organized by FIU Institute of the Environment, where myself and Candice are actually a member of that institute. But we have also collaborators from UNESCO Chair for Sustainable Water Security at FIU, Dr. Maria Donoso is here with us. Addis Ababa Institute of Technology at Addis Ababa University is our also collaborator and co-organizers. Bahada Institute of Technology at Bahada University, the Nile Basin Discourse, which is a basin-wide effort. And also the Water and Land Resource Center at Addis Ababa University is also our co-organizers. So today's talk will be by Dr. Hisham Eldardiry, and I'm going to introduce him shortly, but the talk will be part of his dissertation that he has developed a tool mainly for monitoring reservoirs, which will be also very helpful in understanding operations. So it's going to be shedding light from space on dam operations, introducing the Nile Basin Reservoir Advisory System called NiBRAS. I remember once Hisham told us NiBRAS means light. So he's going to talk about the tool that he has developed as part of his research for helping monitoring the reservoirs, particularly hard, and also how it can be extended to even GERD. So Hisham is not new to this forum. He was our guest last time, along with two other graduate students, and he gave us an overview of his research. So Hisham is currently a postdoc. Hisham, I am right, at the Pacific Northwest National Laboratory, NLL, which is part of the Department of Energy USA. And he just graduated a couple of months ago from the University of Washington at Seattle, from the Department of Civil and Environmental Engineering, which is PhD. To go a little bit detail, Hisham has a PhD at the University of Washington in Seattle. He has also another PhD from the University of Louisiana at Lafayette in systems engineering. He has also a master's degree from the same university, but also his base is in civil engineering from Alexandria University, which is in Egypt. So Hisham has been working on research mainly for finding sustainable solutions to the challenge of facing of security of energy and water systems in transboundary basins. In most of these basins, it's very inseparable to talk about energy without talking about the water resources. So he's highly interested, particularly in the Nile River Basin, particularly after the construction of GERD and operation of GERD is going to start soon. And as part of that, Hisham launched a satellite-based decision support system called NiBRAS, mainly for monitoring and reservoir operations over the Nile Basin. Our moderator is Dr. Kevin Wheeler, which we all know. He's not also new. He was our keynote speaker, if you remember, in our last summer conference. Kevin is an Oxford Martin Fellow at the Environmental Change Institute, University of Oxford. Kevin got his PhD in transboundary water management from Oxford University. He has over 50 years of experience as an engineer and also as a project manager, particularly in water resource planning and engineering. He has worked on the development and application of DSS, particularly for long-term water resource planning and management. And he has an ample experience working in the Eastern Nile Basin and also in so many other transboundary river basins, including here in Colorado and also other parts of the world. So let me just introduce one upcoming talk, which will be on August 10. August 10, please mark your calendar. So Yari El-Basha will be talking about the Eastern Nile systems under 3 different water apportionment alternatives: colonial era, the Washington, D.C. land, which we all know, and also the equitable share. So under these different scenarios, Yared is going to talk about that. Will be on August 10. Please mark your calendar. At the same time, it's going to be a Tuesday also. Some reminders, this presentation will be video recorded, and please be aware. Please mute your microphone for the duration of the presentations, and also unmute to ask questions after presentations indeed, and time for Q&A. You can send a chat to the moderator for questions or comments. Now with that, I will open the floor and give the mic for Kevin to lead this discussion. Thank you very much, everybody.
Okay, well, it's a privilege and honor to take part in this forum again. We've been following Hisham's work for the last. He's one of the few people I know with 2 PhDs. I'm not sure why you'd go back for a second PhD after one, but he had the courage to. But we're all very grateful because he's published some excellent work in the last several years, and a lot of it driven from a lot of the stuff he'll talk about today. I imagine the eyes in the sky and the use of satellites. So we've learned a significant amount from his work, and we see that definitely as a movement not only in the Nile Basin but across the world, with the ability to have satellite imagery provide a lot more information than was provided before. And I want to start out maybe with the challenge of what the value of the satellite imagery is and how that affects the dynamics within a shared river basin. I think that's something we all want to think about as Hisham describes his work. They're tremendous tools. And how do we integrate that into the decision-making process when river basins cross international boundaries? What are the pros? What are the cons? Without any more delay, I'd like to go ahead and hand the microphone over to Hisham. What I would say is please ask your questions. Put them in the chat function, and we will collect those. And I will log some of those and ask some of those at the end to Hisham. And please, Hisham, let's go ahead.
Yeah, thank you, Asif and Kevin, for the introduction. I just start sharing my screen. So can you see my slides now, right?
Yeah.
Okay, great. So yeah, so I'll be talking today, as Asif and Kevin mentioned, about the system that I recently launched for the Nile River Basin, which is called NiBRAS, or Nile Basin Reservoir Advisory System. And the idea of the system is to make use of the available satellite missions and or observation to monitor the dam operations in the Nile River Basin. So just a quick introduction from the Nile River Basin, which probably most of you would know. It's the world's longest river that's in northeastern Africa, crossing 11 countries. Here, as you can see, it has also two sources: the White Nile, which is contributing to about 14% of the flow, and the Blue Nile, and also the other rivers in coming from the Ethiopian highlands, which contributes to about 86% of the flow. Also, another important aspect about the Nile is that it has a very large population, and more than 200 million people are living next to the river basin. Especially if you see, for example, a country like Egypt, it has now more than 100 million people, and about 95% or more of the people are just living next to the Nile River. And this chart is showing the portion of population for each of the Nile River Basin country, the portion of population that are living next to the river or inside the Nile River Basin. You can see that the country like Egypt or Sudan, about 90% or more than 90% are living just next to the river basin. So one of the big challenge in the basin is actually the building of the new dams. But if you look here at this map, which is showing the different states of the dams, for example, here the green triangles are showing the existing dams, and one of them which is currently the largest dam in the basin, is the highest one dam, controlling the flow into Egypt. But also, according to the database developed by Darf et al. In 2015, there are about 35 hydropower dams that can come in the future into the basin, and probably will complicate more the water management in the basin. And 4 dams are currently under construction, and one of them is for sure the Grand Ethiopian Renaissance Dam at the border between Ethiopia and Sudan. This dam, you all know, it's currently under construction. It's expected to be the largest hydropower dam in Africa with a storage capacity of 74 kilometer cube. And it will be controlling the flow in the Blue Nile. And as we follow the news, it's creating a political tensions between the Nile countries, especially Ethiopia, Sudan, and Egypt. So some of the challenges in the basin, as I said, it's a transboundary river crossing 11 countries, which makes this system very complicated in terms of managing the water and maintaining a sustainable water resources for the Nile countries. Another challenge is the planned dams, and as we have seen recently, the construction of the GERD is raising these political tensions and is a challenge for most of the countries, especially as downstream countries. Another thing is also the increasing in the population, which will probably lead in an increase for the demand of the food and energy for the Nile countries. But one very important challenge, which will be the focus of this talk as well, is the data availability and sharing. And we can look at this challenge from 2 dimensions. One of them is the data availability, because of the countries of the Nile Basin are developing nations, so they don't have enough in situ network of measured data. So the data is most of the time is not available. But the other dimension of this challenge is that even if the data is available, is not shared between the Nile countries, and this is making the research or taking the decisions becomes more complicated or more challenging for the Nile countries. Another challenge for the basin is the climate variability. And when we talk about the climate variability, we need to know whether the climate is dry or wet, so we can make a better decisions about the future. So the overall question or the overarching question of my research, and this was part of my PhD research at the University of Washington, is trying to drive an adaptive reservoir operating policy under these impacts of different challenges in the Nile River Basin. And when we talk about adaptive reservoir operating policy, I'm showing here a schematic of the amount of data that we need to develop an adaptive reservoir operation. And as you can see here, it starts with having data for the water levels, or having data for having data for the water level, or having the data for the flow through the river. So we can also build models and building database for different water variables. And then it comes later to making the decision, which is here number 4 and 6. And this will probably what I will talk more about in my system, is having a decision support system that helps in making the decisions, and also informing the stakeholders, especially in my case, it can inform the dam operators or the water managers or farmers in the Nile Basin. So what I will introduce today is the NiBRAS system, which is a satellite-based decision support system to advise the reservoir operations in the Nile River Basin. And the idea of the NiBRAS is actually to offer different tools that can help in real-time monitoring of the reservoir operation, and also can help in building scenario assessment. For example, the idea is to offer a tool that can help the user to assess different scenarios of, for example, the GERD filling or GERD operation, and see how this can impact the downstream countries. This is just an example of how the scenario assessment can work in the system. But this work, the scenario assessment tool is still in progress. Another thing is also offering the data, which is mostly from the satellite observation, which is free. So the user can also download the data and analyze this data based on his scope of work. And then the last thing is helping in informing better decisions for different stakeholders. So I will give later a live demo of the NiBRAS system, but for now I just want to give an overview of the system and its different components. So the system is based on a satellite framework that I developed for my PhD work, and it integrates different models. So it integrates an hydrologic model in the back end, and also reservoir modeling, which is basically using a water balance approach, and also another model for estimating the water consumption or the water used by the agriculture sector using a satellite-based approach called ET. As you can see in each of these components, you can see that we are using satellite observations. And in my presentation here, or even the system now, is currently using only the two dams, the highest one dam and the GERD, as an examples or typical examples of the dam operations in the basin, especially that HAD can represent an existing downstream dam, and the GERD will be representing a planned upstream dam. Some of the themes of the system that I will introduce is actually that it's integrating big data, which is a satellite observation plus modeling, using hydrologic modeling or reservoir modeling, plus also cloud computing, which is something also that the system is making use of by processing the big data through the Google Earth engine. So the NiBRAS, as I said, it's integrating these different models together in the back end, and then provide the end user or the front end user with an interface to facilitate displaying the results and also making decisions. So the two parts of this system is the back end, which is most of the research that I have done, using the hydrologic model that I will show later, which is in my research. I'm using the VEC model, which is a model that developed here at the University of Washington, and also reservoir modeling based on the water balance approach. And all of these are using the forcing from the satellite observation. And then the other part of the system is the front end, and the front end is what actually the user will see. So the user, how the user will display the results, what tools are available for the user. And in my case, the front end, actually, I'm providing the user with two things. One is the outputs from the hydrologic model, and also the outputs from the reservoir modeling. So if we start talking about the back end, I just want to introduce very quickly the hydrologic models that I use here. As I said, I use a VEC model, which stands for Variable Infiltration Capacity Model. And this model was developed a long time ago here at the University of Washington, and still maintained here by a research group here at the University of Washington. So I developed this model for the Nile Basin, and using a spatial scale of 0.1 or degree, and it's running every day using forcing from mostly from the satellite observation. For example, the precipitation is coming from the iMerge, but what I want just to highlight here, that this model is running here in our computers here at the University of Washington every day, and so it's providing the outputs every day for the system. And the idea is the idea of using the iMerge is actually because it has a real-time product, so we can produce every day the amount of the flow in the basin. Here are also some of the results that we have, and these results are actually from this paper we published 2 years ago. It's showing the calibration of the model parameters at the Khartoum station at the daily scale and also the monthly scale. I just want to show you that the results were the results from the model are in very good agreement with the observed flow at the Khartoum station at both the scales, the daily scale and the monthly scale. Just very quickly, I mean, the left panels are showing calibration period for 5 years, and the right panels are showing the validation period for another 5 years from 1998 to 2002. And as you can see, the R-squared in most of the cases is very high, and also the even the NSE I remember is also was more than 0.5 for the Khartoum station. The other component in the back end is reservoir modeling, and some of the questions that we are trying to answer here using this model is how is the High Swan Dam, for example, is being operated? Can we infer the operation of High Swan Dam using the satellite, or what is the water level over the High Swan Dam reservoir? And based on that, we can also understand how much water is being released or stored every month at the High Swan Dam. So we use this water balance approach, which is a very simple equation. It's saying that the outflow is equal to the inflow minus source storage change minus the evaporation over the High Swan Dam lake. The inflow is coming from the VIC simulations. The storage change is coming from combining different satellite observations together. In my case, especially, I'm using the altimetry, using Landsat, and also using the SRTM to develop an area elevation curve, which is I'm showing here in the in this left panel. This is area elevation curve of the High Swan Dam, and then this is also, I mean, this figure is the water level from the altimetry over the High Swan Dam, and comparing the altimetry to the observed water level, we can see that the R square is very high, and they are matching very well with the altimetry is matching very well with the observation. And the last thing is also to calculate the energy, the evaporation losses over the High Swan Dam every day using an energy balance method. So based on this, we can infer the operation over the operation over the High Swan Dam, and showing here an example for 5 years from 1998 to 2002 using this approach. And the blue line is showing the simulated or the model using the satellite approach, and the red one is showing the measured. And as we can see that in most of the months, they are the model is very close to the observed flow, except for some of the months here in the late in the fall, from September to November, when the model is underestimating the High Swan Dam releases. And there are different reasons for that, especially the uncertainty in the inputs from either the forcing into the VIC simulation models, or also the uncertainty in the water balance approach itself. But in general, the satellite-based modeling, we have proved in our paper that it's showing a good agreement with the measure discharge, and it can be used as a framework to monitor the reservoir operation in the Nile River Basin. Another thing also in the back end of the NiBRAS is to look at the filling of the GERD, or the Grand Ethiopian Renaissance Dam, and see how much the dam is being filled every day, again using the satellite information, as I will show later on the live demo. I will not go through this, but this is actually showing some of the information about the GERD. It's located at the border between Ethiopia and Sudan. Using SRTM, I also produce the aerial elevation, the relationship, and also in the system we will have the inflow every day into the GERD, and this will be based on the VEC models that I'm using in my work. And the VEC model, for example, is showing here also how the variability of the flow into the GERD. Then the second part of the portal development, of the system development, is the front end, and the front end is combining different tools. I don't want to go into details on that, but I just want to highlight that one thing that we are using is the Google Maps API. Also we are using different languages like JavaScript, HTML, CSS, all of these languages to write down the scripts for the portal. And also another thing that I mentioned is the cloud computing. So most of these satellite observations are processed through the Google Earth engine, and you know that we used to do this kind of satellite processing of the satellite data using the GIS or other softwares, but in that case we have to download the data, which is also taking too much storage in our computers. But now using the cloud computing, we are able to do all of this processing on the cloud. And so making it easy in terms of saving the storage and also saving time as well for producing the outputs. So here's a NiBRAS system. I'll show you now a live demo. So it has currently different tools. So it has a tool called MRO, or monitoring of the reservoir operation. And this tool is currently operational, as I said, every day, checking the highest one dam, see how the highest one dam is being operated, and also provide information about the inflow, the storage change, and also the outflow or the release from the highest one dam. Another tool is to monitor, it's called MRI, or monitoring reservoir initial impoundment, which is basically now working for the GERD, checking how much of the GERD is being filled. Another tools that will be coming in the future based on the work that I have is using the forecast information also to inform the operation of reservoir, it's called the FARO tool, and then there is other tools in progress. One is a scenario-based assessment of reservoir operation, which, as I mentioned before, trying here to provide the users with different scenarios and testing these scenarios and see how this will impact the operation of the dams. Then we another two tools using the satellite information is to monitor the temperature of reservoir, which I think is something also very important, especially for the environmental flow or the ecological system into the basin, and how, for example, the question is how GERD will impact the temperature of the stream. And I will show. I mean, so I'll show you an example of how we use the satellite information for the highest one dam to see the change in temperature upstream and downstream of the dam. So how the dam is impacting, because there is, I mean, most of you probably know that the dam is changing the temperature of the stream in the upstream and the downstream. And then another tool is to monitor reservoir sedimentation. I think this is also be important to see how much of the sediment is stored by the dam or blocked by the dam. So I'll start now showing you going to a live demo for the system. So when we open the system here, so this is the system, the NiBRAS Reservoir Advisory System, and again, here is the tools. There are different sections here. I mean, this is the home page. This is an about section where we go here. Just a quick introduction about the NiBRAS system, the tools that are here, and then here are also some of the research focus or the themes of the NiBRAS. One of them is, as I said, the hydrologic modeling or building hydrologic model for the Nile Basin, and using satellite remote sensing. It has also this reservoir operation research and also river forecasting, which is still, as I said, in progress. And if you go here, you'll see some of the work that or the papers that we published related to this work or the NiBRAS system. And then we also provided technical training. Last year, we organized this workshop here at the University of Washington. It was virtually, which is called Sensing Rivers, and it was providing the participants from different countries, especially from Egypt, Sudan, and Ethiopia, and the use of the satellite information, and also how to build a system like NiBRAS. So this is just the home page, but then if you go here is the different tools. For example, if you go to the MRO tool, I mean, if you just click here, then we will, it should work here. Yes. So let me just, so if you go to the MRO tool, this tool, for example, then we have here, we have two products. As I said, the system is pushing the results from two products, the reservoir modeling and also the hydrologic modeling, and the home pages are for each tool is showing the reservoir modeling output. So we have different satellite missions that we retrieve the satellite missions over the highest one dam. I mean, in the case now, the system is running for the highest one dam, so we are retrieving the satellite observations from 3 different missions: the Landsat 8, which is it's a mission by NASA and the USGS here at the US, but also other 2 European missions, which is a Sentinel-2 and also Sentinel-1. So we have these 3 missions over the highest one dam. So now it's only highest one dam is highlighted, which is only available, but I hope in the future we can also include other dams like GERD, Rosaris, the Owen Falls in the upstream at the Lake Victoria. So I hope we can all add more dams, but for now I'm only I have for the highest one dam. Then we can select the date which we want to show the results. And just to something I just want to highlight here, that in most of the times the data is delayed by 1 day, and the reason for that is the time it takes to retrieve the forcing data, especially the iMerge data, and then pushing the results into the system. So for today, for example, is 20, but the results should be available for the 19th. So I think today 20. No, I think because yesterday was 19, so it should be available for 18, which is the day before yesterday. So once we submit here to generate the maps, yeah, just to say again about the dates, because there is a little delay, because here in the US we are like 6 or 7 hours difference between the Pacific time where I'm located now, and also the computers that are running the models are located, and there are 6 hours difference between the US Pacific time and the GMT time or the UK time. I think it's 7 hours, I think, or 6 hours. So this delay plus also the delay or the time we need to run the models. So for example, the results for yesterday, which was 19, should be available today afternoon by the US time, which will probably be the night on the Middle East or on the UK time. So that's why I think the results for the 19 is not available now, which is yesterday, but the results for the day before yesterday is available, which is 18 July. So once we submit here, we start to see here is the highest one dam lake. So this is actually based on the Landsat data. We can see the lake of the highest one dam and how much of the lake is filled, so how much of the water is stored behind the dam. And this is actually we can for different missions we can see. And you can see, for example, here for the Sentinel-2, there is some problems here, and this is expected from the satellite missions. And that's the idea why I'm providing different satellite observations. So if there is some problems or issues with some of the satellite images, then you can use a more reliable satellite mission. For example, here Sentinel-2, it seems like there is a problem with the image over the highest one dam for that day. And then again, Sentinel-1 also is showing here, but Sentinel is much better, except for some of the areas here. It seems for that day, Landsat 8, it's producing a more reliable results for the highest one dam. So the other thing I also want to share here is that we have different layers. So one of the layers, this is a basin boundary, but the Nile streams, we have something called the NiBRAS watch, and NiBRAS watch is the main dams that are being monitored by NiBRAS. And for example, currently the station or the dam that's is being monitored by the system is only the highest one dam. So this is only NiBRAS watch that's available. Also, another layers is the existing dam and the future dams. So this is the existing dams. If you stop at any of the dams, you can see the name of the dam and where it's located. And also here's some of the future dams, which are shown here in these red circles. But what is the NiBRAS watch offers is that we can, if you look here, the NiBRAS watch, it will offer the reservoir inflow, and you can see this is the inflow from last year up to the most recent data. I think it's 17, or might be also, I think it should be 18 or 17. So it's showing the most recent inflow. I think I just need to maybe refresh the system to get the most recent data, but overall it's showing the inflow into the highest one dam, the most recent inflow into the highest one dam. This is the inflow. The other thing is also the storage change, and this is using different satellite missions. And as you can see, it's showing the altimetry, showing the using the Landsat. You can also show the Sentinel-2. In Sentinel-2, there is no big change. Probably there's some problems with the images. Actually, when I was checking that with the Sentinel-2 images over the highest one dam. And this is, for example, the Sentinel-1. So, for example, if you want to compare between the altimetry and the Sentinel-1 as well, here's the storage change. And also another output is outflow from the water balance over the highest one dam. Again, using different satellite observations, you can navigate through the different satellite observation and see the differences. Here's also the area elevation curve for the highest one dam. It's derived using the SRTM, and the storage elevation for the highest one dam. And this data is retrieved from the HydroWeb, which is another website I think maintained by the French agency. I think this French Space Agency is, if I'm correct, but it provides altimetry over the Lake Nasser or the highest one dam every day or whenever the data is available from the altimetry. So this is the NiBRAS watch, and this is the products, or the first product, which is a reservoir modeling output. The second product is the output from the hydrologic modeling, and again you see the same interface for the tool, the Mri tool, and then here's the sub basins, and I'll be showing the model now for the Blue Nile, which is running now every day. So I'll be showing some of the output from the model for the Blue Nile and the hydrological variable which is available. We have different variables: precipitation, evaporation, runoff, base flow. We have also the daily the temporal scale is daily and monthly scale, and then again we select the date here, and as I said, I think 19 is it's not working. It should be 18. So here's a precipitation, for example. This is the daily precipitation over the Blue Nile. So here is the precipitation over the Blue Nile, and you can see, for example, if you want to compare the difference or something between the precipitation for different dates over the Blue Nile. So this is a simple output or product from the hydrologic model. Is only showing the forcing data or the output from the VEC model. You can also check the runoff or other things. The other pages here in the tool is if you want to have some information about the tool. I'm just providing here some text about the tool, the dam that's currently being monitored, which is the highest one dam, the cross section of the dam. So it's showing some of the information about the tool itself. And then the user guide. I think the user guide for this tool is not available, but it's similar for the other tools that I'll be showing later. So this is the first tool. The second tool that I want to share is the Mri tool, which is to monitor the impoundment or the filling of the girth. Yeah, I think it's. So this tool, when we go to this tool, it's the same interface like the MRO. It has two products: reservoir modeling and also the hydrologic modeling. And here I'm showing the reservoir modeling output for the girth. So let me just yes. So if I refresh it, it will show you something like that. So here is the basin, and the only NiBRAS watch here is the girth. So the girth is the focus of this tool for now. Again, it has a different satellite missions. It will be showing the filling of the girth using different satellite missions like Landsat, Sentinel-2, and Sentinel-1. Again, the reservoir it's only now available for girth. Another thing I'm also providing is different contour or different elevations for the girth. And the idea here is to just give the user an idea if the dam reaches this level or not. So we can, for example, see, and that's what I will be showing now, if the girth, for example, reaches this level of 586 or not. And this is some of the key elevations for GERD, but we can add other actually elevations, and maybe the plan in the future as well is to make to give the users the flexibility to check the GERD elevation. And then again, the date here is available. I think we have to just go one date back. And then when we submit to generate the maps, it will show you how much of the GERD lake is filled. So just to explain this, so here what we see is this gray boundary is the elevation at the filling of the GERD at elevation of 655, which is probably the full when the GERD will be fully filled. So so for now, up to yesterday or 2 days before, the GERD is only filled. This is only the amount of the water that being filled by the GERD. I mean, this is expected, but it might be interesting. For example, if we check a lower level like 550, 450, and what we can see here, this is actually, you can see that 550 is already mostly filled. I mean, this is the gray line is showing the boundary of the contour for the 550 elevation. So it's mostly filled at the 550 level. If you go up a little bit to 586, we can see that it's not completely filled. It didn't reach to the level of 586, but it's, I mean, about like 80% of the contour is already filled. So probably the GERD now is at an elevation between the 550 and 586. And this we can check it for different satellites. If we don't believe in, I mean, if you don't trust the Landsat 8 for this, for example, we can see also the Sentinel-2, how it looks like, or the Sentinel-1 as well. And this can be interesting if you, for example, you want to check it for last year and see, is it different for last year than this year? Yeah, you see, this is what was last year. This last year, in the same date, July 18th, it was. This is only this that was what was filled out last year based on the Sentinel-1 data. If we compare it to this year, so it might be interesting to see this. It changes in the filling of the dam. Another thing in the reservoir modeling output is again the NiBRAS watch icon, which will give you information about the inflow into the GERD. I just want, I think, to zoom out a bit here. Yeah, so it will show you the inflow actually up to the most recent one. I think it's just not showing 18. I think it needs like to zoom in a little bit to see the flow 2 days ago. But anyway, it's showing the most recent flow based on the hydrologic model. Also, the area elevation curve is here, again, based on the SRTM. And then based on that, we can also infer the elevation from the different satellites. It's showing here that the elevation is, as I said, there is some actually outliers from the Landsat, but in general, the most recent image from Landsat was in July 6th. And it's saying that the elevation, based on the area elevation curves that I have, it's about 550, which might be a little bit from what I've heard from the news. It might already exceeded the 550, but this is because of some uncertainties in the area elevation curve, and also uncertainties in the way that we estimate the water area over the dam. But overall, it can give you a trend on how much of the dam is being filled, and also the elevation of the GERD. But we need to check this also with some official numbers, or check this with other sources as well. It's showing here the Sentinel-1, the most recent image was also, it's actually giving a mostly the same or very close elevation. And the most recent was also, I think, in July 6th, or maybe even, I think I remember there is a more recent image for Sentinel-1 maybe. So again, here it's showing for another one is the Sentinel-2. Still, there is some outliers that we need to clean for some of the dates. And based on the elevation, is also similarly, it's showing also the impounding storage over the GERD. Another thing very quickly is sorry, is the hydrologic modeling, and it's showing the inflow into the GERD, which is similar to what I've shown, but also giving you the maps for the different outputs over the upper Blue Nile. So, for example, give you the precipitation here over only the upper Blue Nile. It's very similar to the first tool that I showed, but here is only it focuses only on the GERD and upstream of the GERD. Again, here the MR. Again, this is about page if you want to check the cross section for the GERD, and also some of the storyline of how how the story has developed, or the GERD and the complications in the Nile Basin. And here is also the user guide is here available now for the MRI. If you go here, you can I just prepared this guide with some of the instructions of and how to use the MRI tool, and you can see here how to use it, and it explains everything in detail, and you can check this as well, and how to display different outputs and results. So I want to go back to just here to so this is the two tools which are currently operational every day. The other tools are still in progress, but the last two tools are actually I just tested very quickly. I will show you how it will look like. I mean, this is the old version of the system, but I will push this to the new portal. But just to show you how it will look like, the temperature, it will give you the temperature at the reservoir, also the climatology of the reservoir. This is the location of the reservoir itself, and then it can also show you the upstream, so you can compare between the. I mean, the idea is give you to compare between the temperature of the stream at the reservoir location and also upstream of the reservoir or downstream of the reservoir. So this is how it will look like when we add the temperature into the system. Another thing is also the sediment. Again, it's showing the sediment at the location of the reservoir, upstream of reservoir, and also downstream of the reservoir. So this is just an example of how this will look like when it will be added to the system. I think I'm almost done. I just want to share something very quickly from the slides, that some of the future tools, as I said, will be to test the different scenarios, and this is some examples for the scenarios that the user can test from when using the NiBRAS, is to check the GERD filling scenarios, a stream flow variability, storage level in head, and see how this will impact the highest random operation, or how to also derive an adaptive operating policy for the highest one dam. Another tool will be the FARO, or the forecast-based adaptive reservoir operation. Again, there will be different inputs into this data, but the idea is to make use of the forecast information so that we can know, for example, if the next year is a dry year or wet year, and how to adapt or change the operation of the reservoir according to this forecast information. Also there is the opportunity to use some of the future meshes in the future, or integrate this into the model, especially the SWAT mission that it's expected to be launched next year in 2022. So this will be the first mission that's dedicated for the water, and it can also provide very important information about the rivers, reservoirs, and the lakes. And we also can there will be an opportunity to include this or integrate this meshing also into the system, as I showed, like Landsat or Sentinel-1, but we also can add these future meshings into the system. As I mentioned, we have organized this workshop last year to train the participant into different topics related to satellite remote sensing, reservoir operation, and building this decision support system. We are still now working on having similar event this year, but I'll share with all of you if we are planning to hold this workshop again this year. This is some of the papers that basically drive this system and drive most of this work. I think I will stop here, and I'll be happy to take the question, and thank you again.
Okay, well, thank you very much, Hisham. That was excellent. I think you really sit at the forefront of how the Nile Basin is changing from a system that's difficult to get information on to one that information is going to be more and more readily accessible via satellite, and hopefully via increased transparency. Yeah, that was excellent. We've got some questions starting to come in, but I guess I'll start out a little bit with kind of a general question I'm interested in. The footprint of the VIC model, is that basin wide, or is that focused only on the Blue Nile, or do you try to simulate the SUD? What's the extent of that tool?
So for the hydrologic model is currently running only for the Blue Nile.
Okay.
Because we have run it for the entire basin, but there are some problems with the model to simulate the flow into the White Nile, and I think this is something that's I have seen in many models, and the reason is probably for the sod lakes and this area of the lake that the model is not able to capture it. So in our model, we focus on the Blue Nile, and the justification is because it's sharing most of the flow, or contributing to most of the flow into the basin. But we add also the other flow from the White Nile, but using only the climatology average and also the standard deviation of this of the historical flow.
Okay. Yeah, I've got so many questions for you that I built up through the years, but I'll go and ask some of the questions that are coming in. Really, first one right now is from Belena. Asks, where is the hydrological and meteorological data that was obtained to calibrate and validate the model? Where did that come from? Because obviously it's so they're difficult to get, or where the validation calibration data, where's that acquired from?
So yeah, the validation and calibration data is actually from the observed data published by the Ministry of Water Resources and Irrigation in Egypt. We have this volumes of I think it's called like HERST, I think, the volumes from that published by HERST that has the discharge and the measured discharge at different stations over the Nile Basin, especially at the stations in Egypt and some of the stations in Sudan. But this data is available only up to, I think to my information, is only available up to 2002 or 2007. After that, it's not released anymore, and that's why the calibration and validation period is between 1993 to 2002.
Yeah, that aligns with what I've seen too. Yeah, that HERST data, all the old books, all the big green books go in multiple chapters up to 2002, but beyond that, they're not. So I understand your questions there. Other questions at all? Let's see. I saw a hand up. Admasu Gibehu, are you? I see your hand up right now. Do you have a question to ask? I don't know.
You're muted.
Hand might have gone up. Are you still muted?
I'm saying good afternoon according to my time, and good morning according to yours. Hisham presented a very interesting topic, and as far as I'm concerned, he's been successful in presenting it. I will go more deep into that when I sit with my students, with my PhD students, as well as my colleague here, Dr. Perletta. I'm sure we'll sit together and assess this model in detail. In the meantime, I want to ask just one question. The calibration is done at station, Khartoum station. Would you please take me to that slide?
Yeah, sure. This one maybe, right?
Let's see. Yeah. Mm-hmm. The upper part of the where you have the measured and the simulated. My observation from this chart is simulated are almost all the time, or except very rare cases, has exceeded the measured, means there is a systematic error here. If you appreciate this comment, do you have any way of adjusting it? Because it is adjustable, as I can see, because it is systematic. So the first one is, do you think this is something that need to be adjusted? Or do you think it's quite acceptable for your purpose?
Mhm.
So that's
Yeah,
my question here.
Yeah, thank you. Yeah, thank you for the question. Yeah, I mean, I agree that there is a little bias or a little overestimation from the simulated flow. I haven't done like any correction, like separate correction other than the calibration that I've done for the parameters. But I might need to look more at this and see, because I'm just worried if we try to, because doing this bias correction, if you do it over the entire time series, then we might also see that at the low flow it will be underestimated or something. So I think I need to look at it carefully again and see if I do this bias correction, it will not impact the lower flow or the upper flows, especially the peaks. So yeah, thank you. And yeah, I think I'll consider this for this bias correction and see if there is a systematic error that can be checked, or and to improve this, to improve the simulations at the Khartoum station. Yeah, thank you.
Yeah, it's a good question, and all of us modelers know how long and painful the calibration process can be, and you adjust one thing one place and it messes up another place, but calibration is never a finished process.
Yeah.
Always recalibrating, and particularly when we get more and better information. There's a question by Mohammed Bashir. He asks, are reservoirs between the GERD and the HAD considered in the river system model? And if not, would including them improve the estimates at the High Aswan Dam?
Yeah, thanks, Mohammed, for the question. Yeah, I think this question is yeah, it's a very good question, because yeah, I've been asked this question many times. So yeah, in my research, in my work, it's we didn't consider the dams in between. We only considered these two major dams, the GERD and the High Aswan Dam, and we justified that because we have looked at the flow into the reservoirs and CNR, and we have found that these dams are not impacting that much the flow that's coming into the High Aswan Dam. And but I'll be very happy to include this into the system, because I think probably after this will, especially the Reservoirs Dam, will be directly impacted by the GERD. So I'd be very happy to include more of these dams, especially the Sudanese Dam, Mri, CNR, or Reservoirs into the system, as long as we have information about these dams.
Excellent. Yeah, and as Hisham knows, myself and Mohammed Bashir both work a lot in reservoir operations. So I think combining a lot of the fine scale runoff that you're able to do with the reservoir operations that others work on, I think can be a very powerful merger of capabilities. So yeah, so that's a good question. So along the same lines, how is the equatorial Nile considered in modeling the water balance of the High Aswan Dam? Another question from Mohammed Bashir before we move on.
Yeah, as I mentioned, the White Nile, we haven't considered because the hydrologic model was not working or is not calibrated well over the White Nile. So we only considered the climatology of and the standard deviation as well of the historical time series or historical flow from the White Nile. So we didn't go into much details of the equatorial regions and their impacts on the High Aswan Dam. But I'm currently working on improving the VEC model, using a different version of the VEC model that can also incorporate the water management and especially the dam operation and the water use for irrigation, and see if this can better simulate the flow into the White Nile. And I think, and then we can see the differences at the High Aswan Dam, or how it can be, the flow can be changed based on the White Nile. So, yeah, thank you.
Yeah. the soot is a notoriously difficult area to simulate because of just the hydrologic challenges. And
yeah, I think, I mean, if I remember correctly, and I think Mohammed can correct me as well, I think he's using a different model, Mohammed, in his research, but the model is, I think, is one of the inputs is actually that is giving the boundary condition as the flow from the White Nile, I think at Malakal Station or something. So Malakal Station is already downstream of the region which has most of the problems in the White Nile. But in my case, the model is different. It's a semi-distributed model, and it needs a lot of information, and that's why it's not easy to calibrate it over the equatoria and also the sod lakes in the White Nile.
Okay, excellent. I don't know if Mohammed Adam, that answered all your questions. I probably can let you ask that, but let's move on to the next one. Let's see here. Akil Girma. Actually, go ahead and just unmute your microphone. I'll let you guys go ahead and talk. Ask your question to Hisham directly from Makele University.
Okay, you can hear me?
Yes.
Mm-hmm.
Okay, thank you, Hashim. Really, it's very interesting presentation, and your work is really, I appreciated your work. The question I have is why other reservoirs are not included? Is it because that the inputs that you need for preparing for the models are difficult? I would like to see also for the other reservoirs. And if it is difficult, how can we be of help? You know, can we really support, you know, in your modeling or anything? So I am very much interested, and if you like any assistance, or if we have to be in any help, then you let me know. Thank you. That's my main question, and I really appreciate the work you've done so far. Thank you.
Yeah, thank you very much. I really appreciate that. You are true. I think part of it is because of the data availability for, especially for to validate the operation of most of the other dams. So the data is not available. This is true, and I'll be very happy to work together and try to add more the other dams as well. And the other thing, I mean, that we are looking at the big picture of the Nile Basin, looking at the large reservoirs, and see how this will be impacted by the GERD or checking the operation of these dams. So I think, I mean, this is just like an example of how the system will be working, and we are using these typical dams like GERD and HS1 dam. Because the information, as you said, is available, but I think in the future we might need to collaborate with other countries and having information about these dams, so we can include the dams in between. And yeah, we can get in touch and try to add more dams as well. Thank you.
Great, and that's what a lot of this is about, is to figure out what the needs are of certain researchers and what other researchers can help fill those needs and share some of these resources. One question that I've had that Gebertikan Tefera asked, can you export the data into Excel or any other format now? You have images where the product is the footprint, and you can see some of the graphs, but is the data itself exportable to be able to analyze?
Yeah, I think that's a good question. Yeah, you can do that. I think if you go here then you see, if you go to this icon, then you will be able to view a full screen, for example, here, and then you can just move the Zoom screen. You can download like it's images or PDF document. So this, for example, but I think for now we can also add this as downloaded as an Excel as well, and I can add this option. But for now, the options available is just in images. But yeah, I can add to download the data as a CSV file or something. But yeah, this is available format for now.
And that's certainly the desire of most researchers, is to look at the data. The challenge, of course, is making sure that that's always flagged when you download it, that this is modeled data, because a lot of times that the data has legs and starts running around and being used by other people. So it needs to be able to always be flagged and identified what the source of it is and the metadata and all that type of thing. But having it downloadable would always would be a huge benefit to the research community for sure. No doubt about
Right.
that.
Yeah, I agree.
Let's see here. There's a good question here from Tagaya Diminis Lemma. How do you think the data sharing policy in the future? How will that shape up since the political issues are not yet resolved? And what's sort of your vision on how this ability to download data or find data remotely? How do you think that would help change the data sharing policies between the countries? So it's a difficult question, but any thoughts on that?
Yeah, I think it's a difficult question. We don't know because it's I mean, the situation is already very complicated, but I'm not sure about the future, what will be. I think data sharing is very important so that the countries in the Nile Basin can coordinate together on how to operate the dam. So I think even when they talk about reaching an agreement, I think the very important component or part of this agreement is to work on the data sharing in the future. And a very good example for that is the GERD and Roseras Dam, for example. As an example, I think coordinating the filling and the operation of GERD and also the operation of Roseras, this will entirely based on the data sharing. So I think in the future, data sharing is very important. Reaching a data sharing policy between the countries is an important thing to consider in the future. But yeah, I don't know how this will look like in the near future, especially with what's going now in the basin.
Yeah, it's always a very difficult task in trying to figure.
Yeah.
It's not just us technical people, but it's also a political question. I often feel like there for a long time data has been a securitized issue, and now we're seeing the disadvantages of having a securitized issue when systems like this are becoming more and more available. You want to make sure that the data is both accessible as well as quality too.
Right.
Abete's got a good question. Does the model accommodate forecasting such as drought? Yeah, so we'll start out there. What do you have in mind for forecasting into the future? And sort of what kind of timescales would you be looking at for forecasting?
So the forecasting work we already did this work. It's actually based on a monthly forecasting of precipitation and temperature over the Blue Nile. So we looked at a lead time up to 12 months. So this data is available from NMME model, which stands for North American Multimodal Ensembles. There are different models. I think we have done like 8 models. So having the precipitation and the temperature for 12 months of a lead time over the Blue Nile, this will be the forcing for the hydrologic model. And so we can, running the hydrologic model, we can produce the stream flow into the Blue Nile for 1 year ahead. So, and then we can use that for testing different scenarios or checking how the dam can operate in the next year. So this is actually what I meant by the using the forecast. It will be to forecast or predict the flow for 1 year ahead. And probably it's important because we can if we have a good information about the next year, if it's a dry year or wet year, then we can make probably better decisions in dam operation.
Yeah, it's a very important and challenging piece. Now, I'll do a follow-on question to that. Of course, the uncertainty in forecasting is always pretty tremendous. Even on the Colorado River, the other river that I work in, every month they basically generate 30 new forecasts because we don't really know what the most likely thing is. So forecasts a year into the future, while they may be possible, they're not very reliable. One of the challenges particularly if you look at a lot of the proposals that are being discussed on the GERD, is they rely on a knowledge of how much water is going to come into the system to decide what the operational plan would be. And you don't know that for sure until after it's happened. So do you have any thoughts in terms of how often one might need to conduct a forecast, or what is the level of reliability, I guess, of these forecasts as we get closer and closer to the runoff period to try to decide what the total annual inflow is for into the GERD? Any thoughts on that?
Yeah, I think that's a very important point, because this is actually what most of the time the decision makers, they don't want to use the forecast because of the forecast skill. And I think you are right. We need to consider the forecast skill, and sometimes it's I mean, we do already a bias correction for most of the forecast models because it's highly biased. But as you said, the question is what is the time when the forecast skill is reliable. And I think when I did it for the Blue Nile, I think we have found that the skill is, as expected, is going down as the time is increasing or lead time is increasing. So 1 year probably is less reliable than if we look at the 1 month lead time forecast. And I think in this case, what I would propose is to maybe rely on different products and also different scales, and keep updating the forecasting, because every month these forecasting models are producing the precipitation or temperature. So we can also every month we can update the operation of reservoirs based on the new data that's coming into the system. But yeah, I think that it's a bigger challenge to when we consider the forecast skill, as you mentioned.
Yeah. I see Asif has his hand raised, so we'll hand it back over to our.
Yeah, thank you, Kevin. Thank you very much, Hisham, for the wonderful presentations. I want to comment a little bit first before I go back to my questions. It is the question regarding data sharing. I mean, the unfortunate part of it is going to undermine the effort that Hisham and other models are doing in order to actually understand how transboundary river basin management are actually functions, because the question comes, how was the data monitored, who owned the data, and everybody is going to ask if they don't like the result of the model, then they're going to come into the data question. So unless we really have a very uniform approach or mechanism by which data is actually being shared and accepted by all parties, it's going to be actually a challenge for people like Kevin and Hisham are actually doing in order to model all those processes. I think with that, the question, I have a couple of questions. One is, how do you resolve the scale mismatch between the satellite data and your simulations? You are simulating on a daily basis or real time sometimes. The satellite data are actually more than a day old. That's the first question. And the second question is there any country or any group within the Nile Basin countries who are actually very welcoming your model outputs, particularly how are they going to actually incorporate it into their monitoring of reservoirs and filling, especially given at this point, the model seems a little bit requires some refining, and given that the issue is very highly sensitive, how are you going to actually look into all of those things?
Yeah, thank you. So for the first question about the scale mismatch, yeah, you're right, because most of these satellite observations are they have a temporal resolution of, for example, Landsat. It's available around every 16 days. Sentinels are available every 6 days or more. So what we do here is in terms of monitoring the reservoir itself, we actually run checking every day if there is a new image or not. If there is a new image, then the system will show that there is a new image. If not, it will just use the most recent image. So the idea is using the most recent image for the satellite observation or the satellite image over the reservoir. I think this is a question in terms of the temporal scale mismatch. I'm not sure if you are also asking about the spatial scale as well, or only temporal scale. But the temporal scale, we use the most recent image. That's why when I showed for the highest one dam or for the GERD, the most recent image was July 6, for example, in the Landsat. And what I showed as a map is again, this is, if the image is not available, it just shows the most recent, which is July 6. So this is how we produce the maps on the system. The second question is the countries which are interested. Yeah, I think because the system I just launched this system recently, but yeah, I was visiting Egypt in May, and I got just the chance to talk to the people in the Ministry of Water Resources and Irrigation, and they are willing to start sharing the data to improve the outputs from the results, especially the highest one dam operation. And they said so they will provide like the water level, for example, so that we can, and also the outflow, so that we can kind of validate the system outputs, or calibrate also some of the parameters, so that we can better understand the operation of reservoir. The other thing which I think it will need more refinement is also for the GERD, especially the area elevation curve. And you might have seen that there might be a little underestimation in the GERD filling, and the reason probably is because of the area elevation curve. But I have even tried different area elevation curve in the literature. One of them was I cannot remember the references, but it was the papers that just published last year by, I think, I can't remember the reference exactly, but this actually is the area elevation curve that I have from SRTM is giving the highest elevation. So even if I tried different other area elevation curves available from the literature, it will give even lower storage elevation. So I think having a data like the area elevation curve, which is very key for the operation of the dam or the filling of the GERD, I think having something like this from Ethiopia, for example, will be very helpful in improving the outputs in the system and making these refinements.
And I'll add a lot of those elements, the area elevation curves, those are increasingly available to get the kind of the official engineering ones. And so I think as those are accessible, then you'd have the ability to replace the ones that are driven by the DEMs, which have an inherent error in there, to the ones that have been developed through bathymetry surveys. So you'll always be able to continuously improve them.
Yeah. So you mean, Kevin, like it's accessible and available, or not yet?
Yeah. So a lot of the studies that I've done and others have done get the elevation area curves from NBI, which got them from Ethiopian government, from the design documents as well. So
yeah, I think I used the one also used, I think, in the last paper, the one in Nature. I think you have it in the appendix, this area elevation curve for the GERD. But it's still, I think it's that's what I checked, and I think it's giving even lower area elevation curve compared to the one I have for MSRTM, which is, if I use even in my system, it will produce a lower storage elevation for the GERD. So but you are right. I mean, probably this is more reliable, and it might be the issue in something else, maybe the area that's produced by the Landsat or something, not the area elevation curve. Yeah, there is different sources of uncertainties.
Lots of ways the error can slip into these, especially when you're modeling the reservoir operations.
Yeah.
Another interesting question that I have that's very relevant and on the table right now is the question over seepage and how much water is being lost from reservoirs, not just the GERD, but from all different reservoirs. And I'm trying to understand that question a little bit. Does any of the stuff, I know the gray satellites and some of those things can do some of the overall mass. Do you have any thoughts in terms of being able to use, I guess, being able to use the satellites for one seepage and another one for evapotranspiration? Have you thought about how to incorporate those into?
I don't think I've done any work related to the seepage. The only thing I've done it was like looking at, I was working with some collaborators at the Alexandria University in Egypt, and we are looking at the the water balance over the Toshka lakes, which is just on the west side of the Hyaswan Dam, and using the GRACE data. But the GRACE data just provides a total water storage, and we are trying to see if this can provide some indication of how much of the water is being, or maybe just give some idea about the seepage, because there's some satellite sensors which are available. Also, there is a soil moisture SMAP, but I haven't looked at that in my work. But I think it's worth to have a look and see how much is seepage, because I think it's very important, as you mentioned, for the Hyaswan Dam. It's very important because some of the water is being percolated into the soil, or there is part is being there's a seepage part in the water balance of the Hyaswan Dam that goes sometimes to the Toshka Lake. So I think it's important if there is a satellite that can infer something about the water storage or the percolation.
Yeah, and that seepage can either be deep percolation or it can be shallow percolation that comes out in the agriculture downstream and reemerges downstream of the dam. So that's also a very challenging thing. But my feeling is that you're getting all of these first and most important steps of getting the mass balance, and then it can be refined as the tools and satellites are improved and methods are improved. Stefan, until what time do we have this scheduled?
Well, do you see any questions from the audience?
Let me go back to the questions here. Let's see where we're at.
Maybe another 5 minutes. If not, I mean, you can go. It's already 9:20.
I have a question. I raised my hand.
Oh, please. Sorry, go ahead, please.
My question is, flow is supposedly underreported historically, and there is also very high flow error. So when you calibrate your model against the historical data, what is the importance of ground truthing, actual program to measure flows with the current technology? And that will be a good validation for the remote sensing modeling, and it will have a better chance to be accepted by everybody. Ground truthing is done inflow at Aswan, outflow at Aswan, inflow to GERD, outflow, and the rest of some areas in the middle.
So do you mean the parameters that we use for calibrating the model, right? If this is the question.
Well, you match your simulated flow to the historical flow. Historical flows have two kinds of errors. One, measurement, technology, and everything else. Two, it is assumed that underreporting will benefit Egypt. For example, it says that it gets only 84 billion cubic meters. Annually, it might be over 100, or these issues have been raised by issues and even in publications. So when you fit your model to this kind of data and without any ground truthing being done, which is the best way to validate it, to get actual flow that matches to your modeling.
Yeah, I see your question. I think we consider the observation as like the observed flow or the measured flow as our reference. So that's what we believe in. I mean, we trust the observed as the observed flow as the best reference for to calibrate the model. And I think when what you mentioned about the Hyaswan Dam, for example, or the flow in Egypt, the model is actually calibrated at two stations in the Blue Nile, not in Egypt. So it's calibrated in Khartoum and also in Aldim station, or the station that's where the GERD is very close. Yeah, I didn't consider this sources of error in the measurements itself, but I'll be happy if you have any thoughts or ideas to how to improve this, because I haven't done any work to improve the measurements before. So, and if there is a new technology, I'm not sure if the data is available or not, because to the best of my knowledge, and I've used the most recent data available, which is from 1993 to 2007, but beyond that, I haven't found any data available. But even this data is also showing that, I mean, you mentioned that the data sometimes, the water coming to Egypt saying like it's 84 kilometer cube, but sometimes it's more. And the measured data is showing something like this as well. It's not like a fabricated data that it will end up anyway showing that Egypt receives only 84. No, sometimes it's showing that Egypt is receiving more 84, or sometimes it's less based on the year, if it's a dry or wet. So yeah, I think I'll be happy if you have any ideas or thoughts on how to improve the measured data, or these another sources of data to use. So
no, I mean, the past you can do nothing about, but for the model, a better chance to be accepted for application is a new program of measuring flow at this time, and that will be will be used for the remote sensing calibration, and we will have a reference and most likely use that for decision making or any kind of water sharing. Without that, this background will always be there when model outputs are presented. That's all I have.
Yeah. I think what you're saying is true, that maybe the calibration of or we can do a better job maybe with a satellite modeling or something. So I think if I get your point correctly, I think I agree that maybe we need to improve the satellite modeling, especially if it will be used for decision making, and the information is very sensitive. Then I think we, as Asif also said, doing this kind of refinements is very important. Yeah,
and it's in particular in stream flows, because it's hard to. It's hard to know exactly what the source of the error is when you're trying to do a mass balance. And if anybody here has built stream gauges, there's a in the United States where I built stream gauges, if you get it within 8% passing one side of the next, and you're within 8%, that's considered good. You accept those. So there's if we think about the variation of 8% in a gauge is pretty significant. So that there's just intrinsic errors. Then there's also errors when you're trying to do a mass balance, like Hisham is trying to do, in terms of demands. When you have ungauged tributaries and ungauged demands, how do you factor those in? I know a lot of people have tried to come up with methods, and that's why I was probing about using the satellites to try to get an idea of demands in areas where they're not monitored or not reported or monitored. To try to complete the mass balance in a good scientific way. I think we have one more question. Dr. Elias Gibehu Ayele, are you? Please ask your question. I see your hand up.
Okay, thank you very much for your very nice, interesting presentation. So I have one question around the water balance at HUD. So in the computation of the water balance, then you consider only the inflow from gauged and ungauged stations, and the change of storage and evapotranspiration. Then I don't know why you consider like the precipitation is equal to or approximately 0. So from the water balance computation, then the change in storage is the difference between the inflow and outflow. Maybe the inflows are coming from gauging streams, ungauging streams, and also area precipitation and groundwater inflow. So then this one is working for other reservoirs or other dams, because there is no like precipitation, area precipitation, then groundwater inflow, and also groundwater outflow. So what are your assumptions, and also what is the limitation of this assumption? Okay, thank you very much. This is my question.
Yeah, thank you. Thank you, Elias, for your question. I think you're right. I mean, we considered the precipitation over the highest one dam is 0, which is, I think, true, that there is the rainfall over this area is almost true. Most of the precipitation happens in Egypt is happening far north in the Delta region. So that's why the assumption that precipitation is almost zero is, I think, is true. But even if the precipitation is not zero, we can just retrieve this from the TRIM or the iMerge data. So for applying this in other dams, I think it's still okay. And this is something I did it, for example, for the GERD. When I consider the water balance over GERD, I have to consider the precipitation over there. So the precipitation cannot be equal to zero for other dams. I'm not sure this is answering your question, and this is one of the assumptions. The other assumption about the groundwater, I think it's true. If we have information about the groundwater, we can also give a mention about the seepage and the percolation or the water losses. So if you have information about that, we can add it, because now the current model or the water balance model only considers the losses due to the evaporation. But if we have information about the groundwater, then that will be that can improve also the water model. And we did that, as I said, in other work that I didn't show it here. When look at the Toshka lakes, and we find that the water balance model can be improved even, especially when we consider also the water that's going to the Toshka lakes and consider some other satellite sensors like the GRACE. So this work we are still working on now, but I think there are many opportunities to improve the model.
It seems like the Toshka Lakes would be a very ideal situation to look at those people, because since it's a closed basin, you can track where all the water goes in the end. You know what's being diverted or pumped, and you know what you could use a satellite to estimate the evaporation, and you can assume the rest is either being used for percolation or for the evapotranspiration, I guess. So,
right. Yeah, I agree.
Okay. I think that's probably time for us to call it an end. You agree, Asifa?
Yeah. Thank you very much. So thank you very much, Hisham, and also Kevin, for leading the discussion. It was very nice of you, Kevin, to accept this help right after your long travel. And also, Hisham, thank you for waking up before 5 a.m. in Washington State in Seattle to actually make these presentations. You have been very generous. And also, thank you very much, everybody, for coming and for joining us. We'll have another one on August 10. Same time, we will send reminders. I hope you will join us. And thank you very much, everybody. Again, have a wonderful day or evening. Thanks a lot.
Thank you. Bye.
Bye.